Good morning friends. In this lecture I am going to solve the important problem on one-dimensional heat flow equation. Or students, one-dimensional heat flow equation. Let us see the problem, students. The ends capital A and capital B of a rod 20 centimeters long have the temperature. Okay students, what is bar length, students? What is bar length? 20 centimeters, students. 20 centimeters. Now what he says, the ends, say this is A and this is B, students. AB. Okay, have the temperature at 30 degrees centigrade and 80 degrees centigrade. One end here it is 30 degrees centigrade and the other end is 80 degrees centigrade. Okay students, until steady state condition prevail. Okay students, you give the temperature, these two both ends temperature until steady state, students. Steady state. Okay, steady state temperature. Then what he done, students, if the temperature of the ends are changed to 40 degrees centigrade and 60 degrees centigrade. Okay students, what he done now? He changed the temperatures. Okay students, one end is 40 degrees centigrade, here increase, students. Okay, the another end is 60 degrees centigrade, that means here decrease. Okay, now when the temperatures are changed, find the temperature distribution in the rod at any time t. That means you find U at any time t. You find U, temperature U at any time t. Okay students, now if you observe diagram here, whenever we get a steady state, the temperature is now we consider initial temperature, students. Okay students, here it is a initial temperature. Okay students, again if I change the temperature on both ends, what happens in the bar, students? What happens in the bar, students? There is some disturbance, students. So then what is the, how can you find the temperature, students? How can you find the temperature? US of x plus ut of x comma t. Okay students, there the temperature we can calculate there. US of x means, students, whenever you change the temperature 40 degrees centigrade and 60 degrees centigrade, again it reaches steady state, students. Steady state, that is why I mentioned here US of x, that means it is a steady state temperature. Now again if I stop the temperature, okay, stop reaching the steady state, okay, then what happens, students? Again gradually temperature decreases, students, when time increases. So there is a transient. So transient, the first letter is t, so ut of x comma t. Okay students, once again the complete problem is, initially there is the temperature 30 degrees centigrade and 80 degrees centigrade. Okay students, then the steady state means, you know the equation. Let us see in the problem. Okay, there you get a value, students. That value is initial temperature, students. Thereby he changed the temperature 40 degrees centigrade and 60 degrees centigrade. Now I want to find U at any time t, students. So find U, that means it is US of x plus ut of x comma t. That means it is enough to find these two values, students, by using boundary conditions. Let us see the problem, students, now. So solution, it is a one-dimensional heat flow equation, students. So heat equation. What is heat equation, students? Dou U by dou T, that is equal to C square into dou square U by dou x square. So this is 1, students. This is 1. Now initially it is a temperature, students, 30 degrees centigrade and 80 degrees centigrade. So steady state solution, I want to write here steady state Steady state. Question: when it is steady state, it is independent of time, students. Steady state means it is independent of time, students. Independent of time. So we get here dou square u by dou x square is equal to 0, students. Is equal to 0. Now symbolic form. What is symbolic form, students? D square into u, that is equal to 0. You can also write d square u by dx square because u is function of x now. Okay. What is auxiliary equation, students? What is auxiliary equation? D square is equal to 0. So roots are 0, 0. So complete solution u is equal to c1 plus c2x into e power 0x, students. E power 0 into x. The value is 1, students. So that it is enough to write c1 plus c2x. Okay. Now initially what is temperature, students? 30 degrees centigrade and 80 degrees centigrade. So u of, now here u is function of x, students, only. That means initially a means here 0, x value 0, students, at a. So u of 0 value 30 degrees centigrade, and u of what is length, students? 20. So u of 20, another end temperature 80 degrees centigrade. Now see, students, here I am substituting this condition, students. U of 0, that means you get a c1 plus c2 into 0. This value is equal to 30, students. That implies c1 value, how much, students? 30. c1 value is 30. So this equation becomes here u is equal to c1, that means 30 plus c2 into x. 30 into c2 plus x. 30 plus c2 into x. Now second condition, students. U of 20. So u of 20 means x value 20, students. So 30 plus c2 into x value is 20, students. That is equal to u of 20 value is 80. That implies 20 c2, that is equal to, you transpose to the right hand side, students. We get a 80 minus 30, that is equal to 50, students. That implies c2 value 50 by 20. 2 0 0 cancel, we get here 5 by 2. Therefore u, that is equal to 30 plus c2 value, students, 5 by 2 into x. Here u means here u of x, time is independent, students, so 0. That means it considered as a initial temperature, students. Initial temperature u of x comma 0, that is equal to 30 plus 5 by 2 into x, students. This is initial temperature. I want to write here, students. What is u of x comma 0? U of x comma 0, 30 plus 5 by 2 into x. 5 by 2 into x. Say this is 2, students. This is 2. Okay. Let us see when the change occurs at the both ends, what is the solution, right? Let us continue, students. Now here we are finding initial temperature, students. Okay, this part is over, students. Now what he done here, he changed the temperature, students, 40 degrees centigrade and 60 degrees centigrade, students. So at the ends A, temperature have been changed. Okay, students, at the ends temperature have been changed as 40 degrees centigrade and 60 degrees centigrade respectively. Okay students, 40 degrees centigrade and 60 degrees centigrade respectively. Now we are finding here students u value students. So u means u of x comma t, u of x comma t. Again it is steady state students, again it is steady state, and there is another state students, transient state. So the solution is written as us of x plus ut of x comma t. So u of x comma t, that is equal to us of x plus ut of x comma t, ut of x comma t. It is enough to find the solution of u of x comma t students. Say this is 3 students, already we have 2 is u of x comma 0 initial temperature. Okay students, now I want to find steady state students, steady state us of x value students. So again what is condition here students? What is the equation? D square u by dx square, that is equal to 0. That implies u is equal students, we get here c1x plus c2 students, c1x plus c2. Okay students, say this is 4, this is 4. Now boundary conditions. What students? Boundary conditions. What are the boundary conditions students here? 40 degrees centigrade and 60 degrees centigrade students. So u of at 0 at any time t students, t, that is equal to 40 degrees centigrade. So this is 5 students, and u of what is length students? 20. So u of 20 comma t, that is equal to 60 degrees centigrade. Say this is 6 students, 6. Now from 4 and 5, from 4 and 5, u of 0 comma t, that is equal to, see students, x value is 0 here, so c2, that is equal to, what is c2 value students? 40. So c2 value is 40. Now 4 becomes u, that is equal to c1x plus 40, c1x plus 40. Say this is 7 students. Now from 6 and 7, that means I am using condition 6 and applying in 7 students. So we get here u of 20 comma t, that means x value 20 students, x value is 20. So 20 c1 plus 40, this value is equal to students 60. So that implies 20 c1, that is equal to 60 minus 40 students, 20. Okay, 20. That implies c1 value is 1 students, c1 value is 1. C1 value is 1 students. So 7 becomes u, this is a notation is here us students, us, okay, us. So us of x, that is equal to, c1 value is 1 students, so you get x plus 40, x plus 40. This is one solution students, we are finding us of x. So number is 8. Now I want to find transient state solution students, transient state. That means I want to find ut of x comma t, What is solution students? ut of x comma t, that is equal to, what is formula? c1 cos px. Say it is capital A students, capital A cos px, because I am using c1 c2 here students, a cos px plus b sin px into e power minus p square c square t students, p square c square t. Say this is 9 students, this is 9. Now I want to find a comma b students, that means first I want to find boundary condition students, So boundary condition students at 0 and at 20 students, at 20. To find the boundary conditions, I'm using 3 students. I'm using 3. So from 3, how many students? I want to write ut of x comma t students. Ut of x comma t, that is equal to, come on, tell me students, ut of x comma t. You transpose this to students. So we get here u of x comma t minus us of x. So initial temperature students. So ut of 0 comma t, that is not initial temperature students, at the end a. What is x value students? 0. So u of 0 comma t, that is equal to, you put 0 students whenever you observe x. So 0 t minus us of 0. So that is equal to u of 0 comma t value students, 40 degrees. So us of 0, where is us students? Here I have us students, us of 0, that means x value 0. We get a 40 students, 40. So this value is 0 students. Now ut of another end students 20, because length is 20. So ut of 20 comma t, that is equal to u of 20 comma t minus us of 20. So that is equal to u of 20 comma t value students, u of 20 comma t, here I have 60 minus us of 20, where I have 20, us of 20, here students, us of 20. So x value is 20 plus 40, that is equal, again I got 60 here students, 60 minus 60, so the value is 0. So this is 10 and 11. Let us continue students. I write here transient state solution and boundary condition. What are the boundary conditions students? Both are zeros. Okay, and I also write here steady state solution students. Now I want to find the initial temperature students. What students? Initial temperature. So initial temperature of transient state students, ut of x comma t. See students, here initial temperature means t is 0 students. So I want to write here ut of x comma 0. Okay, ut of x comma 0, that is equal to, t value 0 students, please remember. Now that is equal to, see students, u of x comma t, u means u of x comma t, u of x comma t, t means here 0 students, minus, you transpose to the left hand side, that means we get here u of x comma 0 minus us of x. There is no t students, so that is equal to, what is u of x comma 0 students? U of x comma 0, 30 plus 5 by 2 x minus us of x students, x plus 40, that means you have minus students, so minus x minus 40, that is equal to 5 by 2 minus x students, that means 5 minus 2, 3x by 2, 30 minus 40 minus 10. So this is 11 students, this is 12, because I have 11 students here. Now I am using boundary conditions and initial temperature students, So from 9 and 10 students, that means from 9 and 10, that means I am using condition 10 students, ut of 0 comma t, so that is equal to x plus, put 0 students, x plus put 0, so here x value is 0, okay, cos 0 value is 1, so we get a, sin 0 value is 0 students, into e power minus p square c square t, this value students 0, this value is 0. Clearly here a is equal to 0 students, since e power minus p square c square t is not equal to 0. Okay, therefore 9 becomes come on, ut of x comma t, that is equal to, a value is 0 students, here we get here b sin px into e power minus p square c square t. minus p square c square t. Say this is 13 students, 13. Now 11 and 13, that means I am using condition 11 students. From 11 and 13, from 11 and 13, what is the students? Ut of 20 comma t. So ut of 20 comma t, that is equal to x value 20 students here. So b sin x value is 20, so 20p e power minus p square c square t. This is equal to u of 20 comma t value students 0. So this value is 0. Clearly here students, sin 20p, that is equal to 0, because b is not equal to 0 students. B is not equal to 0. Why is b is not equal to 0 students? Already a value is 0. If b value is 0 means general solution is 0 students. So b is not equal to 0 students clearly. And e power minus p square c square t is also not equal to 0 students, because it is a solution. What students? It is a solution. Now whenever we know sin theta is equal to 0 means theta is equal to n pi students, n pi, where n is equal to 1, 2 and so on and so on. So in n plus we have 20p students, so 20p, that is equal to n pi. So p is equal to n pi by 20. Here n is equal to 1, 2 and so on and 2 and so on. Now 13 becomes ut of x comma t, that is equal to ut of x comma t, that is equal to, see students, here I have n is equal to 1, 2, 3 and so on students. So I want to write in summation notation students, sigma n is equal to 1 to infinity. Now I want to write bn students, bn in place of b, because I am writing here n is equal to 1 to infinity, right? Sin px students, p means n pi by 20, that means n pi x by 20 e power minus p square students, minus p square means n square pi square c square into t by 20 square students, 20 square is 400. Okay students, say this is 14 students, 14. Now I am using 12 students here, I am using 12. So I want to write here ut of x comma t value, ut of x comma 0 value, sorry, x comma 0 value is 3x by 2 minus 10. This is 12 students. And ut of x comma t value, ut of x comma t value, sigma n is equal to 1 to infinity bn sin n pi x by 20 into e power minus n square pi square c square t by 400. So this is 14 students. Let us find bn value students. Let us continue students. See, I am using initial number of students now, 12 and 14. Okay students, 12 and 14, from 12 and 14. Okay, what is 12 students here? Ut of x comma 0, that is equal to ut of x comma 0, that means t value 0 students. So where I have t students? Here, e power 0 value is 1 student, so we get this one students. So sigma n is equal to 1 to infinity bn sin n pi x by 20, n pi x by 20. Now this value ut of x comma 0 students, ut of x comma 0 values, this is equal to 3x by 2 minus 10 students, minus 10. Now I want to find bn value students. I want to find bn value by applying half range. See students, I have sine, so sine series. What is half range sine series students? What is half range sine series? Half range sine series. say I want to find Fourier series of f of x in the interval 0 less than x less than c. So f of x, that is equal to, what is form, students? Sigma n is equal to 1 to infinity bn sin n pi x by c. How can you find bn value, students? 2 by c integral 0 to c f of x sin n pi x by c, students. N pi x by c. This is the formula, students. This is the formula. So bn, that is equal to 2 by c, students. What is bar length, students? What is bar length? 0 less than x less than 20, students. So c is 20. So 2 by 20 integral 0 to c. C means 20 here, students. F of x. What, students? F of x. What is f of x? 3x by 2. 3x by 2 minus 10 into sin n pi x by 20. N pi x by 20 into dx. Now apply here integration by parts, students. U v1 minus u dash v2 plus and so on. Now what is u here, students? 3x by 2 minus 10. What is v? Sin n pi x by 20. So that is equal to 10 times. We get 1 by 10 integral 0 to, no students, you write apply formula, students. So bracket u means 3x by 2 minus 10 integration of sin n pi x by 20, students, minus cos n pi x by 20 divided by n pi by 20 bracket close minus u dash. Derivative of x is 1, so we get here 3 by 2. 10 derivative is 0. v2, again integration of this, students. So we get here minus sin n pi x by 20 divided by n pi by 20. Already I have n pi by 20, students. So we get n pi by 20 whole square. Bracket close. Between the limits 0 to 20. 0 to 20. So that is equal to 1 by 10 bracket. Substitute upper limit, students, at the place of x. So 20 means 10 times 10. 3 tens are 30. 30 minus 10 minus 20. Okay, students, because I have my actual 20, I have minus 20, so minus 20. Minus 20. So students, n pi by 20, that means into 20 by n pi. 20 by n pi. Now x value 20, students. 20 cancel. Cos n pi value is minus 1 whole power n, students. Minus 1 whole power n. I know cos n pi value is minus 1 whole power n, and sin n pi value is 0, students. Sin n pi value is 0. So minus and minus plus. See, students, 20 cancel. Sin n pi value is 0, students. Sin n pi value is 0. Substitute lower limit, students. Substitute lower limit, we get minus. Okay. Here, students, x value is 0. We get here minus into minus plus, and lower limit is minus. So finally get minus here, students. 10 into cos 0 value is 1, students. So we get 20 by n pi. 20 by n pi. Sin 0 value is 0, students. Sin 0 value is 0. Bracket close. That is equal to 1 by 10. 1 by 10. I can take in common here, students. 20 into 10, I think so. Okay, 20 into 10 by n pi. That is into 20 already 10, students. That means we get here 10 means 2 minus 1 whole power n minus 20 already taken common by n pi. So we get minus 1, students. Minus 1. So 10 cancel. That is equal to, I get here 20 by n pi 2 minus 1 whole power n minus 1 minus 1. Also you can take common minus, students. That is up to you. So this solution becomes 14 becomes. Okay, students. 14 becomes ut of x comma t, that is equal to sigma n is equal to 1 to infinity 20 by n pi 2 into minus 1 whole power n minus 1 minus 1 into sin n pi x by 20 sin n pi x by 20 into e power minus n square pi square c square t by 400. Now we get ut of x comma t value, students. Actually we find u of x comma t. So u of x comma t value, what is, students? Us of x. What is us of x, students? X plus 40 plus ut of x comma t. Ut of x comma t is sigma n is equal to 1 to infinity 20 by n pi 2 into minus 1 whole power n minus 1 minus 1 sin n pi x by 20 e power minus n square pi square c square t by 400. This is the required temperature of at any time t in the bar, students. Okay, students, whenever he changes the temperatures at the end, what is the temperature, students? How can you find temperature, students? U of x comma t, that is equal to us of x plus ut of x comma t. You get, simply you can get us of x, students. To find you observe the logic, students. To find ut of x comma t solution, students, you first write the boundary conditions. Okay, students, carefully, and then the initial temperature, students. You check the logic there. Okay, students, apply the boundary conditions. You get a comma b values. Finally got ut of x comma t value, students. Okay, finally what is the temperature at any time in the bar, students? That means u of x comma t. That means we add steady state solution and transient state solution, students. Please subscribe this channel, students. Like the video and share it, students, as many as possible. Hope you understand. Thank you for watching this video. Jai Hind.